Now let's take a look at one of the most basic tools of cost analysis, the cost volume profit, or CVP model. Now, right up front, we're going to make a whole bunch of simplifying assumptions. First, we're going to assume that we only have two types of costs, purely fixed costs and purely variable costs. We're going to assume that our revenue follows the same kind of straight line that our variable costs do. We sell every unit for exactly the same price. We're going to assume that we have a very wide relevant range, so that fixed cost is fixed all the way from no production up to the highest level of production that we care about. We're going to assume we have a business that only has one activity. It is one product or one service, so we can talk about one quantity of activity. And finally, we're going to assume that we sell everything we make. Okay, so very easy for a service company. You do an hour of work, you do the work and you sell it all together. We're going to assume it's the same even if it's a production company. We're not building up inventory or drawing it down. Now, despite all those really simplifying assumptions, you'll see this is an extremely useful framework. It is a staple in marketing and economics as well as accounting, and anyone running a business should be familiar with this type of analysis. Let's start by graphing our total costs as a function of our activity volume. So our total cost is semi-variable because there's a fixed component and a variable component. We're going to call the fixed component F. We're going to call the variable cost per unit of activity V, and we're going to call the amount of activity Q. So we can now draw a line that shows our total cost, which is F plus V times Q. Now on the same graph, we can overlay a revenue line. Now remember, if we don't sell any units, we have no revenue, so that's going to start down in the origin, and every unit we sell gives us exactly the same amount of additional revenue. So our total revenue is going to be our price per unit, P, times the quantity, Q. Okay? Now, where these two lines cross, that's where we break even. Our revenue is exactly equal to our total cost. To the left of the break-even point, the cost line is above the revenue line, and so we're losing money. To the right of the break-even point, the revenue line is above the cost line, and so we're making money. In this type of business, we're always going to be better off with more volume. Now, let's graph this in a slightly different way. Instead of showing cost and revenue as separate lines, instead let's show just one line, which is our profit. So first let's take a quick look at this algebraically. Our profit is our revenue minus our cost. Our revenue is P times Q, the price per unit times the units we sell. Our cost is F plus VQ, our fixed cost plus our variable cost per unit times the quantity that we're selling. Okay? So we can now simplify this a little bit and collect terms. You'll see that Q is multiplied by both a P and a minus V. So algebraically, we can represent our profit as P minus V, that whole quantity times Q, and then we subtract off F. So let's make sense of this before we look at a picture. What's P minus V? P minus V is what's called the unit contribution margin. Okay? For every unit, you bring in sales price P at a cost of your variable costs, V. Okay? And so the difference between those is money that you have available to pay off your fixed costs. And every time you sell another unit, you get that unit contribution a little more. Okay? So that whole first term, P minus V all times Q, is what's called the total contribution margin. That's what you have to pay off your fixed costs. Now, when we put this on a graph, it's useful to draw it a little differently. Instead of having the usual graph with the origin in the bottom left, which is where we have no cost and no quantity, well, you know what? Profits can be negative. So instead, we show the origin in the middle left of the graph to give us room to show how much money we're losing if we don't get enough activity. So when we graph profit, you see that with no volume at all, we're losing all of our fixed costs because we aren't getting any contribution margin to offset them. So with zero volume, we have a loss of F. Every unit we sell gives us our unit contribution, P minus V, okay? And if we sell enough units, we get up to that break-even point, which is exactly the same break-even point that we saw when we showed the cost and revenue lines separately. Where they intersect is where our profit is zero. Okay? So now that we are looking at it this way, it helps us figure out what our break-even point actually is. How would we calculate that? Well, the question to ask yourself is, how many times do we need to bring in that unit contribution margin in order to contribute enough to pay off all of our fixed costs? The answer is, algebraically, we can just put the total contribution margin on one side of the equation, the fixed cost on the other, divide both by the unit contribution margin, and you can see, well, here's how many times we need that unit contribution margin in order to pay off our fixed costs. It's just F over P minus V.